Hey, Mr. Dmitrowicz, what's your hobbies?
Well, I have two toddlers, as you know, or maybe you don't know, so I don't have very much time. But COVID has provided some extra time for me. Not gonna lie. So I've started taking up coding, which is on the scale of nerddom. I think pegs right at the top.
You are
How about you?
totally, absolutely a nerd. Awesome.
I'm nerdy, totally nerdy. How about you?
For
What is
me,
your?
I would say I love to exercise. I swim on a very regular basis. I used to do lots of triathlons. I still may do them. But my wife and I have really been doing puzzles. And since COVID happened, I think we've done 11 puzzles. And there's one on our table
Oh,
as we speak. Yeah, it's like, yeah, it's kind of my analog time where I get to just sort of play. Hey, today we want to learn about matter and how we classify matter.
and here's the thing, John. We're scientists, and we have this urge to categorize everything, don't we?
Yeah, we want to classify everything. So why is it important though? Why is it important that we classify matter?
Well, we want to see what things are made up of. Yeah,
Yeah.
if we understand what things are made up of, we can figure out what they're going to do.
So let's copy down this table. So if we're trying to classify matter, what's the first thing we need to ask?
Well, we ask a series of questions. So the number one thing is, even though it says on the notes, can it be separated by physical means? We can simply say this: can it be broken apart by a physical change?
So if I heat it up, it breaks it apart, right? Then if it can be separated by some sort of a physical mean. So a good example of this might be, let's say I've got a mixture of sand and iron. And what I can do is I can stick a magnet in there and the iron will separate from the sand. So that would be the answer, is it yes, it can be separated by physical means.
Or
All
even
right.
let's take an example we use every day. You eat cereal. Any guys fans of eating dry cereal?
Yeah.
And of Lucky Charms. If you pour a bowl of Lucky Charms in there, can you separate out the Luckies from the other
Yeah,
stuff?
just picking it out one at a time. Yeah.
That would be a physical
All
change.
right. So if it can be separated by physical means, then this is called a mixture. And this is called a pure substance. So let's keep down this track, if you will. So if you have a mixture, what's the next question we would ask?
Well, we ask if it's the same throughout. Is the composition uniform throughout? And what that essentially means is, if you take one part of the sample of matter and another part, are they exactly the same?
So if I had a can of Pepsi, okay, and I took a sip of Pepsi, and I took another sip of Pepsi, and another sip of Pepsi, hopefully every sip of Pepsi is going to be the same. So that would be, it's the same throughout. Yes, correct?
Correct. And we call those homogeneous. Be really careful here, because some people like to go back to their biology roots and call it hetero or homozygous. Let's avoid that.
So if it's heterogeneous, that means that it's not the consistent throughout. So what would be an example of something that's a heterogeneous mixture?
Now, clearly, I don't have very much experience with this, but if you ever eat a salad, I'm guessing Mr. Bergmann, as he runs triathlons, does. I'm more familiar, probably a better example would be chocolate chip cookies. But if you take a salad and you take one delicious mouthful of salad and another, you're not going to have the same ratio.
Not the same number of tomatoes or celery pieces or whatever. Yeah. So a pepperoni pizza might be a good example of another heterogeneous mixture. Yeah. So lots of heterogeneous mixture. And in the scientific world, a good example from the world of geology is like a piece of granite has different crystals in it, and those crystals are going to be different sizes. So each piece of granite isn't going to have the same consistency of minerals. So those are heterogeneous mixtures versus homogeneous mixtures. Let's talk about one specific type of homogeneous mixture that's going to be really important that we're going to use, and that's called a solution. Solution is when you dissolve something in something like salt water, or a can of Gatorade would be a solution, and that's a type of homogeneous mixture. Now let's talk about this other thread down here for the pure substances. So if it can't be separated, it's pure substances. What's this question here? What's the sort of filter?
So the question is, can we separate it via chemical change?
So can it be separated by chemical change? There's two questions, of course, yes or no. And if the answer is yes, we call it a compound, and no, we call it an element, right?
Now, if you take a look at the intro that we did, you guys will see that there's a periodic table behind us that has 100 and, depending on the periodic table, 100 and some elements on them. you can't take an element and break it down into anything farther. If you have gold, guess what? You have gold. You don't get anything else. If you have a piece of copper, you're going to have copper. You can't break it into something
So
different.
copper, we have this symbol Cu. So if I have a piece of copper, it's just copper. You can't break it down any further. But, you know, a formula you're all familiar with is water, H2O. That's H's and O's. You can boil water and it won't break it apart. But what you do is if you electrolyze it, you put electricity through it, it breaks it into hydrogen and oxygen. And then that's the point. That's the chemical change where you can say, oh, we can break it down any further. There's actually a lot of interesting history, folks, about the debate over elements and compounds and how they figured this all out way back at the beginning of the history of modern science. We won't go into that, but it's really quite a fascinating study of how they figured out that there were actually elements existed. It was a pretty cool thing. They didn't know. I mean, way back in the early days, you got this guy named Democritus, and he just said that, you know, you've got fire, water, and air or something like that. There are three main elements in the world. And of course, we now discovered there's like, what, 100 and change, and they are best represented by the periodic table. So Mr. D, anything else? Any other thoughts?
Super fun fact. Don't try to electrolyze water. That would end up with a really bad experience for everyone and probably
don't do that.
losing your jobs.
Well, yeah, that's what you put it like you playing your radio in the shower, you'll die. So don't do that. Yeah, that's actually almost happened to me the other day. We had a little flood at the house and water was flowing into the water. And then I discovered that there was a electrical outlet or a extension cord that was semi-submerged underwater, and I'm walking around in my bare feet. And I thought, oh no, this is not a good thing.
So let's file that under discoveries you just don't want to make.
You don't want to make that one on accident. Okay, hey guys, that's how we classify matter. You guys are awesome. We'll see you.
Take care.